Hello student, now we will discuss algebra of limits. Algebra of limits. First rule, product rule. Limit x approaching c of fx into gx is equal to limit x approaching c of fx multiply limit x approaching c of gx. Put equation number 1. Second, limit x approaching c of fx upon gx is equal to limit x approaching c of fx divided by limit x approaching c of gx. Put equation number 2. This is true provided limit x approaching c of gx not equal to 0. Third sum rule, limit x approaching c of fx plus gx is equal to limit x approaching c of fx plus limit x approaching c of gx. This is equation number 3. Fourth, limit x approaching c of fx minus gx is equal to limit x approaching c of fx minus limit x approaching c of gx. This is question number 4. Now, in case 3 and case 4, reverse is not always true. For example, let fx is equal to x plus 1 upon x minus 1 and gx is equal to x minus 3 upon x plus 1. Now limit x approaching 1 of fx is equal to limit x approaching 1 of x plus 1 upon x minus 1 is equal to 1 plus 1 upon 1 minus 1 because it is not the case of 0 upon 0 form. It is equal to 2 upon 0 is equal to infinity, means does not exist because something upon 0 is infinity. Put this question number 1 and limit x approaching 1 of gx is equal to limit x approaching 1 of x minus 3 upon x minus 1. It is equal to 1 minus 3 upon 1 minus 1. That is, put x is equal to 1 as it is again not a case of 0 upon 0 form. It is equal to minus 2 upon 0 is equal to minus infinity, means does not exist. Put question number 2. Now limit x approaching 1 of fx plus gx is equal to limit x approaching 1, put the value of fx and gx, that is x plus 1 upon x minus 1 plus x minus 3 upon x minus 1. Now within the bracket take LCM. This will become equal to limit x approaching 1 of LCM is x minus 1. In the numerator we get x plus 1 plus x minus 3. That is, limit x approaching 1 of fx plus gx is equal to limit x approaching 1 of denominator x minus 1, in the numerator x plus 1 plus x minus 3. This become equal to limit x approaching 1, solving the numerator, in the denominator x minus 1, in the numerator x plus x become 2x and plus 1 and minus 3 become minus 2. So this become equal to limit x approaching 1 of denominator x minus 1, in the numerator take 2 common, within the bracket we get x minus 1. Now because x is approaching 1 implies x not equal to 1 or x minus 1 not equal to 0. So we can cancel x minus 1. So what we left? Limit x approaching 1 of 2 which is equal to 2. Now put this question number 3. Now because infinity minus infinity not equal to 2. Therefore from equation 1, equation 2 and equation 3 limit x approaching 1 of fx, here c is 1, plus limit x approaching c of gx not equal to limit x approaching c of fx plus gx. That's it. That is, reverse rule is not true in this case. Now problem, let us find the limit x approaching 0 of tan x upon x, where x is in radian. Now solution, limit x approaching 0 of tan x upon x, because at x equal to 0, tan x upon x is equal to 0 upon 0, because tan 0 is equal to 0. Therefore, it is the case of 0 upon 0 form. Therefore, limit this become equal to limit x approaching 0 of, because tan x is equal to sin x upon cos x, put this value, so this become equal to limit x approaching 0 of sin x upon cos x into cos x, in the denominator x into cos x. By rearranging this, we get limit x approaching 0 of 1 upon cos x multiply sin x upon x. So there are two functions, 1 upon cos x multiply sin x upon x. Now because limit x approaching c of fx into gx is equal to limit x approaching c of fx multiply limit x approaching c of gx. So this become equal to limit x approaching 0 of 1 upon cos x multiply limit x approaching 0 of sin x upon x is equal to 1 upon cos 0 multiply 1, because limit x approaching 0 of sin x upon x is equal to 1. This become equal to 1 upon 1 multiply 1, because cos 0 is equal to 1. So this become equal to 1. Therefore, limit x approaching 0 of tan x upon x is equal to 1. So this is the answer of given problem. Thank you very much.